Example, given y-axis, x-axis, the point here 0, 7, the point at 4, 5, connect together with a straight line, solid line, pretend it's straight. Then the point 6, 0, connect that with point 4, 5, call this line A, call this line B, shade on the right side of line A, continue at this point shading on the right side of line B, and then find a system of equations. Solution, we'll start the solution by re-sketching. First we'll do the line A, which has a point at 4, 5, and again at 6, 0. Connect the points together, solid line, that's A, and draw the baby arrows. Obviously they have to be on this side of line A to match the shading, the common shading in the picture. So step 1, find A. That's the inequality. So we're going to use the points 4, 5 and the other point 6, 0. We're going to use with this formula the slope m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. That gives us that the slope m is equal to 0 minus 5 over 6 minus 4 equals negative 5 halves for the slope. Now use the formula y minus y sub 1 equals m times x minus x sub 1. So that gives us y minus, we're using the point 4, 5, so minus 5 equals the slope, negative 5 halves, times x minus the x coordinate is 4. That has LCD equals 2. That's the only denominator. So we're going to get rid of fractions by multiplying both sides of the equation by 2. Now we're going to distribute multiplication on the right. Negative 5x plus 20. And then move the 10 over. Negative 5x plus 20 plus 10 is 30. And then divide both sides by the coefficient 2. Y equals negative 5 halves times x plus 15. Now we want the test point 0, 0 to fail because it lives on the side opposite the shading in the sketch. So we're going to test, we're going to choose any direction. We're going to choose, in this case, greater than or equal to, and see if it fails. So y greater than or equal to negative 5 halves times x plus 15. Okay, plug in 0, 0 is 0, greater than or equal to negative 5 halves times 0 plus 15. In other words, is 0 greater than or equal to 15? And the answer is no. That means the point 0, 0 fails. And if it fails, that's good because we wanted it to fail because the shading's on the opposite side. Thus, we'll keep the direction of the inequality y greater than or equal to negative 5 halves times x plus 15. Okay, that's my inequality A. Step 2, we're going to find inequality B. And for that one, we're going to use the ordered pair 4, 5 again, and the other one, which was 0, 7. And that will give us slope m equals difference in the y values 7 minus 5, difference over the x x value is 0 minus 4. So that's going to be negative 2, positive 2 over negative 4, which is a negative 1/2. Okay, now use y minus y sub 1 equals m times x minus x sub 1. Plug in the values for the ordered pair 4, 5 and the slope negative 1/2. So we get y minus 5 equals negative 1/2 times x minus 4. The LCD again, in this case, happens to be the same, 2. Multiply both sides by 2, you get 2y minus 10 equals negative, it's just negative 1, x minus 4. Distribute the negative sign, you get 2y minus 10 equals negative x plus 4. Move the 10 over, you get 2y equals negative x plus 14. Divide everything by the coefficient, you get y equals negative 1/2 times x plus 7. And look at the shading, we haven't even drawn it, let's draw it right now. Here's 7, and it's going to pass through 7 and through this point. That's equation B, and the shading from the graph shows that all the arrows are going to be pointing up in this direction. Okay, so if we choose the point 0, 0 to test, and remember the point 0, 0 is down here, we want the point to fail. So we want, again, the point 0, 0 to fail. And just for a different view, we'll try choose the other direction, less than or equal, see what happens. Okay, so that means we're going to have y less than or equal to negative 1/2 x plus 7 and hope that it fails. So let's go ahead and apply this guy 0, and we ask, is that less than or equal to negative 1/2 times 0 plus 7? In other words, is 0 less than or equal to 7? And see, the answer to that is no. Yes, yes, yes. 0 is less than or equal to 7. So it passes. Instead of fails, that point passes, which is not a good thing. We do not want it to pass. So we're going to use greater than or equal instead. I'm not going to test it because obviously if it fell for the other direction, it's going to pass for greater than or equal. So we have y is greater than or equal to negative 1/2 times x plus 7. Okay, so this will be our inequality B. And we are finished. Step 3, the system is the ordered pair, the pair of equations y greater than or equal to negative 5/2 times x plus 15, and y greater than or equal to negative 1/2 x plus 7. And we have the equal portion in there because we had solid lines, not dotted lines.